right, welcome everyone. Those of you who are already here, those of you who just joined, or those of you watching online into the future. I'm going to talk today about IBC and Solana, where horizontal and vertical scalability meet. First, a bit about myself. So I am Thomas. I'm developer advocate at Polymer Labs, where we work to expand IBC, or the Inter-Blockchain Communication Protocol, beyond just Cosmos, where it originated. And prior to that, I was also a developer relations at Interchain, which was responsible for the most prominent IBC implementation, being IBC Go. And before that, I was a self-taught developer. And so this is really something that I want to bring to other ecosystems as well, such as Solana, to get the word out about IBC and really focus on education. And that is why I'm here today. And that comes with somewhat of confession. I'm not that familiar with Solana. I've basically spoken to some developers and heard second word of mouth. But I do think that there's a good picture on some interesting things, at least, that can either make IBC successful or potentially propose challenges. So I talked about horizontal and vertical scalability. Maybe it first makes sense to look, what do I mean by that? So I guess this is, going back a little bit into history. I would say around 2016, 2017, 2018, when we had the blockchain trilemma. So it was essentially Vitalik, I think, who first posed this, saying that out of the three of scalability, decentralization, and security, blockchains can only easily fit two of them. And so because of this trilemma, there were kind of like different approaches that different blockchain ecosystems, or layer ones, took to overcome these issues. And I think it's specifically interesting to look in the conversation about Solana and IBC, who comes from Cosmos ecosystem, to look at these two ecosystems' vision or strategy to approach scalability. So if we start with Cosmos, so Cosmos always had this idea of having a network, an internet of blockchains of interconnected layer ones. And so because they had this idea of having layer ones that are all application specific and have application specific block space, it is important that they are interconnected, because it's not a general purpose blockchain like Solana or like the Ethereum L1. So that's the horizontal scaling strategy. Whereas on the other hand, Solana wanted to be vertically integrated. So really optimizing the hardware to achieve the high throughputs, the low latency, and the low fees. So these are very different approaches to the problem of scalability. And I think what we can see today is that next to Ethereum, they are like two prominent ecosystems. So it probably makes sense that each in their own, they have made some interesting trade-offs. So something you hear a lot about developers or builders first being introduced to IBC is that they say IBC is too complicated. It's too complex. Like, why do you need that much complexity? And so what I'm going to try to do here is to have three somewhat simple diagrams to show you IBC on a high level. Because I do believe that IBC introduces maybe the right level of complexity. So you have to consider that when you have a very nascent ecosystem with a couple of L1s where there's not a whole lot of activity, then maybe solutions in terms of interoperability that are somewhat simple, they don't really think about the scaling too much, they could work. But once you really have the next bull market, and where there's going to be like a huge explosion of interoperable traffic, then I really think that IBC is going to shine because of some of the design mechanisms that were implemented from the get-go. So these three diagrams are going to be a little bit technical. After that, we'll go into less technical things. So if you're not super technical, please bear with me. So if we look at this, we kind of see on the left three different layers: application layer, transport layer, and state layer. And this more or less corresponds to three layers of abstraction in the protocol, in the code for IBC, which are clients. On top, you have connections, and on top, you have channels. Right? And I try to use the colors to kind of indicate what is what. And so, for example, if I'm an application developer, I want to build apps that are interoperable. Right? So I'm on the left, the top left, I'm an application developer. So I am going to interact with IBC channels. Channels are connected through ports to your application. Ports basically allow authentication for your different channels. And they are essentially a packet conduit per application protocol. So if you have a new application type or application protocol that uses IBC, you would create a new standard, and every single application would have its own channels. The channel is built on top of connections and clients, and it makes sense to look at the client first. So if we have different chains that we want to interoperate with, on one chain, for example, Solana, I need to know what is happening essentially on a remote chain. I need to have a view into the other chain that I want to connect with. And this is where the client comes in. A client is essentially one trusted view, one trusted root of another chain, plus an algorithm to update that view. And then in between channel and connection, channel and client, you have the connection. So I said the client is this trusted view, but how do we get that trusted view initially? If you have the algorithm to update it, you can understand that we get there, but how do we initially create this trusted view? And this is by creating connections with the connection handshake. And so essentially, that means that we verify and connect the client pairs on each of the chains that we want to connect. And then, once that connection is set, we can build a channel, and then the application developer can start building. So some of this I already went over. You see there's a new actor introduced. So what this slide shows is essentially the main ways of interacting with your client. And so usually this is the actor, the relayer, who does this. It's not directly, in terms of the code, interacting with the client, but we can naively think of it this way. And the relayer is going to send client messages to the client. And broadly, you could say, again, I have there, the client is a trusted state root plus an algorithm to update that state. So what are the three most important interactions with the client? Well, first, that's just updating the consensus state. So a client has some parameters, which is the client state and the proof specifications, and it also has the consensus state, which is a very optimized way. Usually it's just the application hash roots to represent the other remote chain. And an update could be just a header that has the usual function of the chain. So if the remote chain is producing blocks, you just every now and then provide a header to update that state. But it could also be if the remote chain has an upgrade, or if there is an update. Another interaction with the client is actually misbehavior, right? So because we are dealing on-chain with a view of a remote chain, there could be some way of misbehavior, Byzantine, either through a hardware mistake or through malicious behavior. There could be something wrong with the consensus protocol of your remote chain. And basically, submit misbehavior means that we can get a proof of this misbehavior onto your host chain, and then the client will be frozen, right? So that means that if there is something happening in the entire IBC network, we can kind of isolate the faults, which is really important if you're going to connect all of the chains. And then the third one is verifying packet flow. And now this one is a different color, it's orange, because it also combines some elements of the channel. And this is really when we are going to send over packets. So what I said before, updating the consensus state is something that is limited to the client. And so that doesn't necessarily involve sending a packet, although it's usually being done before sending a packet. But if we look at sending packets, the client basically needs to ensure that a packet that is received was actually committed on the remote chain, right? And this we can look in a little bit more detail. So again, I tried mostly to remain the different colors. So application on one side, application on another side. For example, you could think of this as a Cosmos chain and Solana, if Solana gets an IBC integration. And so the first thing that you would do as an application developer is provide the ability for users or other smart contracts to send the intention to send over a packet. This is the send packet. And so that application, your smart contract, for example, will then call into the IBC module, and this will release an event. Then the relayer will listen and query proof if they have an event emitted, and then it will submit a received packet message onto the remote chain. And now, the interesting thing that happens there is that when the IBC module on the chain receives this received packet message from the relayer, it will actually trigger a callback onto the connecting app called onReceivedPacket. And this is important because this allows you to build some extra functionality on the receive of that packet. So the application will then send over an ACK back to first the IBC module on its own chain. A relayer is going to pick that up and is then going to relay it to the other chain. And this is another important thing. Some protocols, some competing protocols, they just send over messages, send over packets, but they don't give the acknowledgement. But if you're a builder, if you're a developer, it's really important that you know that this actually was successful, right? That the receipt of the packet was successfully implemented on the remote chain, and then you can have some application composability on top on the on-ACK packets. So this is for the happy case. There's also an unhappy case, or the relayer for some reason was unavailable for the timeout period, and then you can send proof of non-receipt on our chain B, and then you can, for example, if you were sending over tokens, you could unescrow those tokens. So this is the packet flow, and this is something that you will see come back and back again. This is the regular operation of any IBC-enabled application. So that was the IBC side. So when we move back to the Solana side, as we saw in previous presentation, Solana is an excellent execution environment, and I'm sure that a lot of the Solana builders would definitely agree. So you have parallel execution, you have local fee markets, so low fees, low latency, and high throughput. So it's really a great way to optimize for scalability and security. But if you're a Solana builder, right, and you think, okay, Solana is the most performant L1 out there, why actually do I need to care about IBC, or more generally about interoperability? So the first thing is, as we saw in Bo's talk just before, and for those of you watching online, please go back and look at it. We saw that Solana is not just an execution layer. It's great at that, but it could also be used for settlement, for data availability, or consensus. And this is the idea of modularity. So when we briefly revisit the modular thesis, it essentially means that the different functions of a blockchain, you can spread that over different layers on different chains. So for example, execution, settlement, data availability, and interoperability. And if you look at the different functions, you will see the recognizable teams. So Solana, for example, is here, execution and settlement. Data availability, we have Celestia launch, very soon upcoming, actually today. We have EigenLayer and Ethereum can also still be used as a settlement, as a data availability and settlement layer. And then interoperability, we have Polymer using IBC, and then some of the other interoperability players. So the conclusion is, if we have modularity, if we have all of these different chains working together to form a logical blockchain, there is a clear need for secure interoperability. That is the first reason. Now, the second reason, and this was actually mentioned in the investor panel that we had before, definitely check that out if you haven't on the recording. They also mentioned this, but I was inspired on this point by the Bankless podcast on the trilemma. So basically, Solana, Ethereum, and Cosmos were kind of looked at. Was the episode with Mike Ippolito. And the point that he was making was that even though all of these years ago, like I said in the introduction, different technical decisions, different trade-offs were made, what we can kind of see is that they're kind of converging. So the initial thing that both of these ecosystems, or all three of these ecosystems, wanted to focus on, that has, maybe not entirely, but more or less materialized. And now they're looking to tackle that third leg of the trilemma. And so an example of this is Eclipse. So Eclipse basically uses the SVM, but it posts its data to Celestia, and then it settles onto Ethereum. So if you see Celestia as kind of coming from the Cosmos ecosystem, this is a clear example of kind of a hybrid project that takes layers from each different ecosystem that was mentioned over here, and it combines it. So what does that mean? Well, I would say that it means that we'll see converging ecosystems which will bring the ecosystems closer together. We will see hybrid projects using different pieces from different ecosystems. And I think interoperability is then what brings builders in these ecosystems together. And so this is really important. So all of this was about the technical, the specifications, how we build the protocols, how we make interoperability work, which is still technically challenging. But I believe that as a developer, as a builder, it's about more than that. It's about foundation support. It's about community. It's about education. And like I said, I was talking to some developers earlier, and I think this is really something where Solana ecosystem has done really well. Everywhere, everyone I talk to, I hear that they say, oh, there is great support, in terms of grants, in terms of, community building. If I'm a developer and I want to ask some questions, there's always someone to help me out. There's great education. And this is really important. And this comes down to, over here, personal preference. Ultimately, as a developer, I just want to build where I want to build, where I like it. If I like being part of a community, that's a major reason for me to build somewhere. Even if the features at some point in time might be somewhat inferior or somewhat superior, who cares? Like in the future, there's going to be so much innovation. If you think that the Solana ecosystem, for example, or the Cosmos ecosystem, or the Ethereum ecosystem is a great place to build, then interoperability actually makes it so that you can just build where you want, right? And through interoperability, we'll have the connectivity and the application composability that you need to still connect and still build on top of or interact with other applications on different chains in different ecosystems. So we have three reasons to care. One was modularity needs secure interoperability. Second was if our ecosystems are converging, well, then interoperability is going to bring our builders together. And the third, builders can build wherever they want. So at Polymer, we made the choice of using IBC to approach this interoperability problem, and there's a couple of reasons. So we have the trust minimized light client verification. So essentially, we saw the IBC clients, and there's actually some variety in that. It can be consensus-based, but you could also have optimistic clients or clients that accept ZK execution proofs, right? There's a formal specification for IBC. Like I said in the introduction, if you only have a couple of chains with low traffic, maybe some of your solutions that just send over messages and then leave it up to you to figure out if they arrived or not, maybe that will still do. But if we have hundreds, thousands, maybe even millions of chains, or L2s, or whatever you want to call it, then that is not going to scale anymore. We also have permissionless integration. We all believe, I hope, in like an open and somewhat decentralized future, even though, as we saw in the investor panel, there might still be some centralized components. I think permissionless integration is great. And one important one, I want to make sure that I'm not standing in front of it, is that as Polymer, which is going to be a hub, an interoperability hub between different chains implementing IBC for them, we want to be minimally value extractive. Right? It would be easy if you're an interoperability hub to get some users, connect to some chains, and then say, oh, by the way, right now you need to start paying us, and we are going to extract some value from that. That's not what we want, and that's why we picked IBC. And again, if you want to join us in building this future, please reach out to us, and I want to thank you all for your attention.